Okay, so this video is about another homeostatic mechanism relating to the kidney, and that is the control of water. Now, we established last lesson why it is important that we need to keep the body's water content consistent. So if it goes too high or it goes too low, it can have quite a dramatic impact on the cells, and that can lead to damage to the cells, tissue damage, and unfortunately, ultimately, it could end up with death. So what we're going to look at specifically today is about how the kidneys maintain the water balance of the body. And we're going to be looking at this hormone here, which is a hormone called ADH, which stands for anti-diuretic hormone. So we're going to be discussing the function of that. And again, this is a classic homeostatic mechanism involving negative feedback. So we're going to be looking at, we've got a normal level, that normal level changes, and then basically what happens is mechanisms are put in place to put that state back to normal. Okay, so let's have a think about where this happens. So first of all, your blood water content is monitored in your brain. So we've talked about this area of the brain before. We've talked about the hypothalamus and how that regulated temperature, and also it regulates your body's water content. And essentially what it does is it is situated above your pituitary gland, which is responsible for releasing different amounts of your hormone called ADH. So ADH stands for anti-diuretic hormone, and it's key to think about what is diuresis. So diuresis is the production of large amounts of dilute urine. So if you are producing a lot of dilute urine, if you are weeing a lot, that is because you don't have much anti-diuretic hormone. So anti-diuretic hormone tries to stop this from happening. So why might you have different concentrations of water in the body? So your blood might be quite concentrated, it might have very little water in it because you might not have drunk a lot of water, or you might be sweating, or you might have been doing a lot of very vigorous exercise, and you might be breathing heavily, and you might be breathing out a lot of water vapour. You might have very dilute blood. You're not moving around very much. You've drunk quite a lot of water that day. So therefore your blood might be quite dilute. So these are the two situations. So the concentration of water in the blood is monitored by your brain, and then basically what happens is your pituitary gland releases differing amounts of ADH. So here's our normal water level. We've seen this diagram before, we're going to work around it, but this time we're going to go down first of all. So our blood water content decreases. So it might decrease because we have been sweating, we haven't drunk a lot, or we've been breathing very heavily. So our pituitary gland then produces ADH, it releases more ADH. That in turn has an effect on the kidney. And in the kidney, what happens is tubules in the kidney become more permeable to water, and they allow the kidneys to reabsorb more water from the urine. So now our blood water content will go up because we've reabsorbed that back in from the urine, and we'll go back to normal. On the other hand, if we have increase our blood water content, so we felt thirsty, so we've drunk quite a lot, the pituitary gland will release less ADH. That in turn will make the kidney tubules less permeable to water and will reabsorb less water from the urine. Alright, so water will leave the body and our blood water content will decrease and it will go back down to normal. Now this is our normal homeostatic negative feedback mechanism, but there are drugs that can interfere with this mechanism. So common what we call diuretics, chemicals that make you wee a lot, are things like alcohol and caffeine. So they interfere with this mechanism and stop it from carrying out as normal. So this animation shows us the relationship between the water content of the blood, what's going on in the kidneys, and our relative levels of ADH. So we've got normal water levels in the body. So we are producing a normal amount of ADH, we've got a normal level of water. These are our average levels. So what is happening is in the hypothalamus, we're picking up on the water content and they're deciding how much ADH to release. We are now going to go, I'm going to first of all click on not enough water. So it's hot, you've been sweating. If there's not enough water, then what happens is we get an increase in our pituitary gland releasing ADH. So the brain detects there's too little water, the hypothalamus part of the brain, sends a message to the pituitary increases its release of ADH. The ADH travels in the blood to the kidneys, okay, got more ADH now, where the kidney now removes less water from the blood, so it removes less water from the blood, it takes more water out of the urine, and we get less urine produced in our bladder. Also what happens is a message gets sent to your thirst centre and you feel thirsty, but eventually your water levels will go back to normal, and when that happens, so do your ADH levels. We've drunk a lot, we're not moving around, our ADH levels drop dramatically, and now we're going to remove way more water from the blood, so less water from the urine, and we're going to produce more urine, and then that will decrease our water back to normal, and then our ADH levels will go back to normal. So this is a continual cyclical process. Okay, we're always producing ADH, but we're just sometimes producing more, sometimes we're producing less, and it's just going in a continual cycle until we all are trying to keep our blood water content as normal as possible.